Welcome to the introduction of IPv6 for CCNA. IPv4 is the core protocol that defines addressing and routing. However, IPv6 defines the same general functions as IPv4, but with different methods of implementing those functions. IP version 6, IPv6, serves as the replacement protocol for IP version 4, IPv4. The clearest and most obvious reason for migrating TCP/IP networks to use IPv6 is growth. The migration from IPv4 to IPv6 is much more than changing one protocol, in this case IP, but it impacts many protocols. The incredible growth of the Internet over a fairly long time created a big problem for public IPv4 addresses. The world was running out of addresses. The IETF came up with several short-term solutions to make IPv4 addresses last longer, and one long-term solution, IPv6. However, several other tools like Network Address Translation, NAT, and Classless Interdomain Routing, CIDR, helped extend IPv4's life another couple of decades. The IPv6 Protocols. The primary purpose of the core IPv6 protocol mirrors the same purpose of the IPv4 protocol. However, because IPv6 impacts so many other functions in a TCP/IP network, many more RFCs must define details of IPv6. Some other RFCs define how to migrate from IPv4 to IPv6. Others define new versions of familiar protocols or replace old protocols with new ones. For example, older OSPF version 2 upgraded to OSPF version 3, v3 was later upgraded to support advertising both IPv4 and IPv6 routes. Internet Control Message Protocol ICMP was upgraded to ICMP version 6. Address Resolution Protocol ARP was replaced by Neighbor Discovery Protocol, NDP. For IPv4, ARP discovers the MAC address used by neighbors. For IPv6, NDP discovers neighbors. IPv6 defines a shorter hexadecimal format, requiring at most 32 hexadecimal digits, 1 hex digit per 4 bits, with methods to abbreviate the hexadecimal addresses as well. IPv6 defines a header, with places to hold both the source and destination address fields. Even though the IPv6 header is larger than an IPv4 header, the IPv6 header is actually simpler, on purpose, to reduce the work done each time a router must route an IPv6 packet. IPv6 Routing. The IPv6 routing table lists routing information for IPv6 subnets, called prefixes. Finally, in most enterprise networks, the routers will route both IPv4 and IPv6 packets at the same time. The migration strategy of running both IPv4 and IPv6 is called dual stack. All you have to do is configure the router to route IPv6 packets, in addition to the existing configuration for routing IPv4 packets. IPv6 Routing Protocols. Over time, Routing Information Protocol, RIP, Open Shortest Path First, OSPF, Enhanced Interior Gateway Routing Protocol, EIGRP, and Border Gateway Protocol, BGP, were all updated to support IPv6. In addition, these routing protocols also follow the same Interior Gateway Protocol, IGP, and Exterior Gateway Protocol, EGP, conventions as their IPv4 cousins.